Okay, day 2 of 8.3, we are now looking into De Moivre's theorem. De Moivre's theorem to find power of complex numbers, and we're going to use De Moivre's theorem to find the roots of complex numbers. So make sure there's two videos in 8.3. They're both somewhat short, but make sure you do watch both of them. So 2 days, we actually might have about 3 days to look at this because De Moivre's theorem can be somewhat confusing. Okay, let's get into this. So powers of complex numbers. So powers of complex numbers. Remember a complex number, root 3 plus I, you have your real part. Your root 3 in this case is your real part, and the I is like your imaginary part. And the power of that, we're saying take the whole thing to the fifth power. Now, if you think about that, taking this whole thing and multiplying it by itself 5 times, foiling it over and over, will get very tedious and probably end up in mistakes. But instead, we use De Moivre's theorem. Don't worry about this page 600, but it says if z equals r cosine theta plus I sine theta, then for any integer n, z to the power of n, so whatever power we're talking about, in this case it's to the fifth power, equals r, we know what r represents, to the power of n, times the cosine of n times theta plus I sine n times theta. Or we have r to the n plus r to the n cis n theta. Keeping in mind that n is our power. So I just want to make sure I write that down. Your n is representing an integer or your power. In this case, the power is 5. In the example here, the power is 5. So n would be 5. But before using De Moivre's theorem, we must first find r and theta, just like we did before. Given a complex number, a plus bi, we know that this is r equals the square root of a squared plus b squared. That should be the square root of the whole thing. And tangent theta equals b over a, or y over x. Your y value, the imaginary part, over the x part, your real part. Okay, so we already know how to do that. We learned that in day 1. Okay, so here's an example to the fifth power. It's the same exact example that we had up here. We're going to now do this one. Okay, so what's the first thing to do? Let's first find our r, and we'll find our theta. You can immediately write down what n is. N is our power. We already talked about that. In this case, it's 5. But again, how do you find r? Just like we did before, it's the square root of your a value. In this case, it's a root 3, so square root of 3 squared plus your b value. In this case, it's 1 squared. And that's going to equal the square root of 3 plus 1, which is the square root of 4, which is 2. There's a review of day 1. There's r. Then how do you find the tangent theta? Tangent theta equals the y over x. So in this case, it's 1 over root 3. I'm going to rationalize that. Multiply top and bottom by root 3. Gives you root 3 over 3. Keep in mind for the tangent, we're saying at what angle is the tangent theta equal to root 3 over 3? We should know that if you look on the unit circle, it should be right here at pi over 6. Something that you should have prior knowledge about, pi over 6. So now we have our r and we have our theta. Okay, so now no problem. So now if we use this form, r to the n cis n times theta, r r we just found was 2 to the power of n is 5. CIS, that's the cosine theta plus I sine theta. CIS of n again, which is 5, times theta, which is pi over 6. Let's clean that up a little bit. 2 to the fifth power is 32. CIS, 5 times pi over 6 is 5 pi over 6. So this is the polar form. And now if they ask for the rectangular form of the to the root 3 plus I to the fifth power, if they want the rectangular form, we can expand this and see what we have. So if I actually expand the CIS form, it's really just 32 cosine of 5 pi over 6 plus I sine 5 pi over 6. And now let's clean it up. What is the cosine and sine of 5 pi over 6? Well, I'm going to go ahead and make the unit circle. Over here is 5 pi over 6. That ordered pair is negative root 3 over 2, comma 1/2. Should have that on your unit circle. Okay, let's go to the rectangular form then. So the cosine of 5 pi over 6 is root 3 over 2. So I still have that 32. So I'm over here now doing the rectangular form. So now I have 32. Cosine of 5 pi over 6 is negative root 3 over 2. And then we have I sine 5 pi over 6. The sine of 5 pi over 6, 5 pi over 6 over here is 1/2. So I have 1/2 I. And now if I go ahead and distribute the 32, I have 32 times that and 32 times that. 32 times negative root 3 over 2 is actually a negative 16 root 3. And 32 times 1/2 is obviously 16 times I. And this is the rectangular form of this example. If I were to take that, multiply it by itself 5 times, I will get this rectangular answer. And again, here is the polar answer. Okay. Okay, so here's one more example. This one's to the third power. I want you to go ahead and pause, and then I will show you the answer. Pausing means you should be doing the problem. And here you go. So I went ahead and worked it all out for you. Where I said that, okay, I found R. So I took my value here, found R, squared it, to find R, I went ahead and squared the A value. And here's my B value, squared that. Negative 4 root 3 quantity squared is actually 16 times 3. So if you think about that, 16 times 3. 16 times 3 is 48. And then I go ahead and I add 4 squared, which is 16. 48 plus 16 gives me the square root of 64, which is just 8. There you go. To find theta, same thing we did before, b over a. B is 4. A is negative 4 root 3. The 4's cancel out. I rationalize this to get negative root 3 over 3. So there's tangent theta equals negative root 3 over 3. The question is, where is the, what angle is the tangent equal to negative root 3 over 3? Again, you should make your unit circle. When you make a unit circle, okay, where is the tangent negative root 3 over 3? It is definitely over here in the second quadrant. 1, 2, 3, 4, 5 pi over 6. All right. 5 pi over 6, the tangent is negative root 3 over 3. So now I have my theta. And of course, n was equal to 3. That's my power. Now plug it into the polar form right here. So R is 8. We found that up here. R is 8. Right there. To the third power, CIS of n again is 3, times theta, which is 5 pi over 6. Clean it all up. 8 to the third power is 512. 3 times 5 pi over 6 is 15 pi over 6. And 15 pi over 6 simplifies to 5 pi over 2. All right. And then 5 pi over 2, you guys have to think about what 5 pi over 2 is. Really, 5 pi over 2 is taking you all the way around and coming back to just pi over 2. So keep in mind, theta to technically be between 0 and 2 pi. Right, so 5 pi over 2 takes you all the way around. All right. If you were thinking about it, 10 pi over 4, you'd say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pi over 4 is there. All right. But instead, we can just say pi over 2. So I simplified it to pi over 2. So this is the rectangular form. And then for the rectangular form, I went ahead and put the long version, So I put the cosine and the sine, and then we know the ordered pair at pi over 2 is 0, comma 1. That's what I have right there, 0, comma 1. And so in the place of cosine pi over 2, it's 0. That's what I have here. In the place of sine pi over 2, the value is 1. I get that from here. The y value is 1. So I just have I. And so 0 plus I is just I. And so my final answer is 512i. And you could have 0 plus 512i, but 512i is good enough. Make sure you watch the second video.